Yes, hello my dear students, welcome back to St. Composite PU College, Vijaypur. Now in this present video, I'm going to discuss the variation of conductivity and molar conductance. Very important for your examination. And let me write the title, the variation. Okay, here I will write variation of conductivity and molar conductance, or molar conductivity you can say. First thing, that first understand that what is conductivity. And this story starts with the term called as a resistance. The resistance R is the term used to express the hindrance expressed by the conductor for the flow of electrons or flow of charge. And it can be given as 1 by rho. Okay, let me take here. Rho is resistivity, and L is the length of the conductor, and A is the area of cross section of the conductor. The reciprocal of resistance, that is 1 by R, is called here as a conductance. Or simply we can put these equations and we get the formula, that is 1 by rho into A divided by L we get. And again, if I simplify this, I get here K, that is called as kappa A divided by L. Okay. Now K is called here conductivity. Conductivity. Okay. And G is here called as a conductance. You can see the difference in the names. Conductance. Okay, both are different terms here. Conductivity is different. Okay, and conductance is different. Both terms are here different, conductivity and conductance. But at certain point, the conductivity and the conductance become equal. And that is known as here, let me write, the conductance becomes conductivity, or you can say the conductivity is equal to conductance, right? Means that's K is equal to G, kappa is equal to G. When it is possible, when the terms called A and L are one or unit, like the area is equal to 1 unit square, and length should be around 1 unit. That should be 1 unit. In that case, we can say that the conductivity becomes exactly equal to conductance. Now we have to understand that how the conductivity and conductance vary with dilution. The variation of conductivity and molar conductivity with dilution or with concentration, I will write concentration. So this is a title for the study of. Let's go with the next part. Variation of conductivity. Variation of conductivity. Okay. Now we understood that what is conductivity, and it is equal to conductance. So why I'm taking this, because we have to construct a cell. Okay, electrolytic cell we have to construct, and we'll observe how the ions get migrate. And for that, what I'll do, that I will take one electrode. So this is an electrode. This is one electrode. Just let me write here. And here another electrode. Okay. So looking at this electrode at the front side view, it looks like a rod, a straight wire. But in fact, it is a plane that we can represent like this. This is a plane. Right. The same thing we have to write for the other side also. Now, this is nothing but two electrodes. These are two electrodes. The area of each electrode is given by 1 centimeter square or something. 1 unit square, I will write. 1 unit square, centimeter square or meter square, whatever it is. Whatever the electrodes are there, they are connected with the external wire. And we connect with the battery. Possible, you connect with the battery. And then we connect here. Now let me take some ions. I will take some ions here. Okay, because this entire setup is done in a container. Between them, there are number of ions are there. Let me choose two type of ions here. So these are the ions, students. Now these ions start migrating from one point to another point. Means they just get migrate, because all these setup is done in a container. This is a container. Okay. As the number of ions here more, the more the conductivity will be there. This is nothing, right? The distance between these two electrodes is nothing but a 1 unit. This is 1 unit. Okay. Now I will connect this and make it as a cube. It is a cube now. So whatever the number of ions are there in a small cube in this unit volume, that is the responsible for the conductivity. This is the conductivity, right? This is nothing but the conductance, and conductivity becomes equal when the length of or distance between the two electrodes is 1 unit. Is nothing but it resembles a conductor. Okay, it resembles like a conductor. So this is 1 unit volume of the conductor, and therefore we can say that conductivity is equal to conductance here, because the distance between the two electrodes is 1 unit and the area of cross section of the electrode is 1 unit square. And therefore what happens here in the next part, as you can see that if I reduce the number of ions here in this small volume, the conductivity should be decreased. Therefore I will write here greater the number of greater the number of ions in unit volume, greater will be, yes, obviously greater will be conductivity or conductance. We'll write here conductivity, because for unit volume conductivity and conductance both are equal. Next part, on dilution something happen here. When you add here more amount of water, the number of ions get decreased here. Okay, so let me remove here some of the ions. I just remove by dilution. Okay, now the number of ions becomes less. On dilution, number of ions per unit volume decreases. That's decreases here. Decreases. This is important for us for the study. As the number of ions decreases, obviously the conductivity or charge carrying units get decreased here, and therefore because of this reason conductivity or conductivity decreases. This is what it means, that on dilution conductivity always decreases. This is a fact we have to understand. But again there is a variation is there. We'll study that. The first thing, effect of dilution for strong electrolyte. Okay, that we have to go into study here. Okay, effect of dilution for strong electrolytes. Let me draw once again the same cube here. This is one electrode with the area of cross section A, and there is one more electrode is there. Again the area of cross section will be the same area of cross section, and the distance between the two electrodes is there. Now this is 1 unit, and it's going to form a cube. It's not perfect cube, but just I'm resembling that it's a cube. Assume that is a cube. Okay, and in that there are many number of ions will be there. Like, let me write the ions. So if it is strong electrolyte, it dissociates completely. So in this cube there is huge number of ions will be there. Not only positive ions, along with that we have to take here negative ions also. There is huge number of ions. Okay, this is what we represent here for strong electrolyte. Let me write this point. Strong electrolytes dissociate completely. Dissociate completely. They dissociate completely here. And because of that reason, they produce more number of positive and negative ions are produced. More number of positive and negative ions are produced. This is the scenario for the strong electrolytes. But on dilution, something happens. Okay, on dilution, something very interesting happens. On dilution, first thing, as it is a strong electrolyte, on diluting it, the dissociation is not affected because dissociation is completed. As they are strong electrolytes, they are strong electrolytes, they are strong electrolytes. And because of that reason, they get dissociate completely. They get dissociate completely. Completely they get dissociated. And because of that reason, on diluting again the same solution do not produces the new ions because dissociation is completed. And therefore on dilution, as they are strong electrolyte, they get dissociate completely. Hence dilution do not affect the dissociation. So this is what we have right now. So these are strong electrolytes and they dissociate completely. And because of that reason, if you add more amount of water, the dissociation is unaffected because dissociation is already completed. Okay, it's not going to produce new ions there. But here something happens. This is the first point we have to consider. The second point is, as you add more amount of water, the number of ions in this cube becomes less because then it gets more volume. As volume increases, there is decrease in number of ions per unit volume. I'm taking a word here. Per unit volume decreases. There is decrease in the number of ions per unit volume. As the number of ions decreases, obviously the charge carriers are decreased here and conductivity again decreases here. So we can write here conductivity decreases. So hope you understood that. But important is, as you go on adding a water, the volume increases slowly. Okay, and the distance between the ions is also increased. The number of ions which are you can say that which are completely dissociated, so they are also becomes less here. Number of ions in the unit that unit volume also becomes less. Therefore conductivity here decreases. Okay, how it is decreases, whether it is gradual or sharp, that we're going to study in the next part of discussion. So what we have here, so whether it is sharp or gradual, we have to understand that. For this I will take a graph. Let me take a graph here. Let me draw a graph here. So here we have this side we have conductivity, that is a K. Along this direction I'm going to use here dilution I'm going to use. Okay, dilution or a square root of concentration also you can take. As you do a dilution, the conductivity is drop sharply, right? So this is how the conductivity is changing here. Okay, so this is called gradual. Okay, wait. So here the thing is that what the author says here, the decrease in conductivity with the dilution is sharp in case of strong electrolytes. What is the meaning of sharp? Sharp means sudden decrease in the conductivity. So if I have some electrolyte here which is dissociate completely, initially at high concentration it having a high conductivity at the point here. As you dilute, a little bit of volume is increased here, the conductivity drops here and somewhere here also. So these are the points where the conductivity is go on decreasing as you increase the dilution. So therefore I'm going to write here the graph like this. This graph indicates that there is sudden decrease in the conductivity as we increase the dilution. Okay, so this is called as a sharp decrease in conductivity. In conductivity. Okay, this is one part of discussion. Next, same type of explanation we expect from the weak electrolytes. The effect of dilution on weak electrolytes. So this is little bit complicated to understand the dissociation of weak electrolytes here, because as we know that weak electrolytes are partially dissociated. Let me draw once again the same cube. Okay, so why I'm drawing the cube, because I want to show here that how the weak electrolytes are dissociated. We need the cube here. Cube is nothing but a small unit volume in that the ions are present. Okay, so let me draw some ions here. So these are the some ions. So already there are less number of ions are there because it is weak electrolytes, right? Weak electrolytes means they dissociate partially. That way I also mention here. The first point, weak electrolytes dissociate partially. Partially they get dissociated. So you can see that the charge carrying ions are less number of ions are there, less number of ions. So this is a scenario. Weak electrolyte dissociates less, and therefore less number of ions will be there for the charge conductivity in a unit volume, because these are the electrodes, right? So unit volume is there. That what I explained in the previous part. But what happens when you do a dilution? Yes, when you do the dilution, on diluting or dilution, on dilution, the dissociation get increases, right? Because they are partially dissociated. As you add the more amount of water, the dissociation get increased. On dilution, weak electrolytes get dissociate more, or dissociation increases. Dissociation is increased. Okay, as dissociation is increased, the number of ions should be increased. Number of ions get increased. You may think that here, as the number of ions get increased, means conductivity should increase here. But in reality, the conductivity started decreasing, because when you add the water, the entire volume is also increased. And along with that, the few number of ions are also get produced here. The weak electrolyte dissociation increases, the number of ions get increased here. But on dilution, the volume is also increasing. On dilution, volume is also increasing. When the volume is increasing in this cube, if you add more amount of water, the number of ions get out, means get removed off from the unit volume. As you do the dilution, number of ions decreases here. On diluting, the volume is increasing, and therefore number of ions per unit volume. Yes, here whatever the number of ions are there, obviously in the first case they are increasing, but volume is increasing, and therefore the number of ions per unit volume, I am using a word here, per unit volume, that is decreases. So overall we have to observe here, one time there is number of ions are increasing, in the other way the number of ions per unit volume is decreasing. So therefore I will write one important statement here, that increase in the number of ions, are get compensated by decrease in number of ions number of ions. You can see that number of ions per unit volume. This is important. Per unit volume is important. Per unit volume. Okay, it means that if I take the first point and the second point, the second point effect is more compared to the first one. Okay, so therefore overall, if you observe on diluting, what happens here on dilution, on dilution, on dilution of weak electrolytes, conductivity, conductivity, conductivity decreases. Okay, it is decreases. Conductivity is decreases. Okay, that's fine. We understood. But how it is? Whether it is sharp decrease or gradual decrease. Let me take an example with the graph. This is a graph. On this side, I will take here the dilution. This is a dilution. And this side, I will take here. Okay, that is, you can say, okay, we'll take a conductivity. Now, there is a weak electrolyte. Is it? Weak electrolyte, in that two parts are happening here. The one is on diluting, the number of ions are increasing. At the same time, the number of ions per unit volume, it is decreasing. One time it is increasing, other time it is decreasing. But this process of decrease in the number of ions per unit volume is done, it has become slow. It gradual it is. So therefore we can say that, so here the graph is looks like this. The graph is like this. So gradual decrease. Gradual decrease. Decrease. Why it is gradual decrease, I will explain once again. So when you add a more amount of water, assume that there is 10 new ions are produced. Already per unit volume there is 10 ions are there. But volume is increasing and therefore the decrease in the number of ions means one ion get decreased there, you get a 9. Okay. So means that the 10 new ions are produced due to the dissociation, but at the same time per unit volume the one ion is decreased, therefore it becomes gradual. Okay, that's not important for the discussion here, but you hope just that you get clear the concept. Okay, now this completes the, you can say that conductivity, variation of conductivity or concentration. In the next video I will explain you that how the molar conductivity get changed with the concentration. Thank you students, thank you for watching it.